Welcome to this lecture on the divide and conquer problem-solving strategy. In this lecture, we're going to discuss both algorithms and recurrence relations that fit this strategy or paradigm. So, in this segment, we're going to focus on algorithms that use this divide and conquer strategy. So here is the general description of a divide and conquer algorithm. It's an algorithm that solves the problem that it's supposed to solve using the following three steps. First, the given problem is transformed or reduced to one or more smaller versions of the same problem. The second step is once you have determined these smaller versions of the problem, you go ahead and solve them recursively. Now, these problems are easier than the original problem because their input is smaller. They are just smaller problem instances of the same problem. Once you have solved these smaller problems, each of them has a solution. The last step is to combine these solutions to these easier problems into a single solution for the original problem, the one that you reduced to the smaller ones. So this is the general strategy called divide and conquer. And any algorithm that follows this strategy is called a divide and conquer algorithm, where the first step is the divide step. The second step is the conquer step. So here you divide the problem into smaller problems. Here you conquer the smaller problems. And don't forget the third step, which is to combine the solutions to the smaller problems into a solution for the original problem. Now, as it turns out, we've already studied at least one algorithm that fits this divide and conquer paradigm. Now, remember the problem of sorting in ascending order a given finite sequence of integers. We've studied quite a few algorithms already, bubble sort and insertion sort and merge sort. And it turns out merge sort is an example of a divide and conquer algorithm. So let me give you the pseudocode description of merge sort again. Remember that it takes an integer sequence of n elements or n terms, and it returns the same sequence but in ascending order. The main step in this algorithm is to cut the sequence in half by finding the index m of the middle element. Then recursively call merge sort on the two halves of the sequence, the first half and the second half, get as results two sorted subsequences L and R, and finally merging these two sequences into the final sorted sequence that the algorithm returns. So it shouldn't be too hard to identify the three steps of the divide and conquer paradigm in this algorithm. Let's illustrate them on a concrete example. So here is one possible instance of the sorting problem. The input is an integer sequence of length 10. Now the first step in solving this sorting problem with a merge sort algorithm is to split this sequence into two subsequences, and this step is performed on this line of the algorithm. So m is the index of approximately the middle element. So in this case, n is equal to 10, n minus 1 over 2, rounded down, is 4, and so the index of 4 to the sequence is this element here. So this divide step ends up splitting the sequence into two subsequences as follows. And the key observation here is that first, this step does not perform any sorting. It does not solve anything. All it does is to divide the original problem, which is to sort the whole sequence, into two problems, namely sorting this sequence and sorting that sequence. And it's very important to realize that these two new problems are smaller instances of the same sorting problem. So for the case of merge sort, this line is the divide step. Now, the second step in the divide and conquer paradigm is to go ahead and solve these smaller or easier problems recursively. So first, we do a recursive call to solve this sequence, and then we do another recursive call to solve or to sort this other sequence, and these two lines in the algorithm perform this conquer step. So the result of this conquer step is two solutions, namely the solution to the first subproblem and the solution to the second subproblem. Notice these are sorted subsequences, and to get an answer to the original problem, which was to sort this whole sequence, all we have to do is to merge these two sorted subsequences, and that's what's performed on the last line of the pseudocode here. And of course, that's the combined step of the divide and conquer strategy. So when we combine these two sorted sequences, namely when we merge them, we got the final sorted answer. So, in conclusion, for this segment, we defined the general strategy called divide and conquer, and we listed the 3 steps that an algorithm must follow to fit in that paradigm or that problem-solving strategy, and we pointed out the fact that merge sort is an algorithm that fits in that paradigm.